Good morning, everyone. Today, let us see the context, language, and grammar. Not all languages are regular. So, what happened to the language which are not regular? Can we still come up with a language recognition? The language recognition are finite automata, wisdom automata, linear bound automata, network machine. So, contextual language is a language class are larger than the class of regular language. Contextual language is superset of the regular language. Supports natural recursive notation called contextual grammar. The application of the contextual language is used to develop a first tree compilers and the example language also can develop. So regular language is recognized by finite automata. Contextual language is recognized by positional automata. An example, and palindrome is a word that reads identical from both ends. For example, Madam, redivider, Malayalam, this binary entry. W is a binary palindrome. Is the regular? Is the language is regular? No. So proof for that. W equal to 0 power n, 1, 0 power n, for example, similar. By pumping lemma, we can rewritten XYZ such as X, Y power K, Z is also to be in language. It is so the language is regular language. Any contradiction comes, that language is not called regular language. Other condition, modulus of XY should be less than or equal to n. Y should not be FCNT. Y at least should be greater than 0 length, more than more greater than 0. X, Y power K, Z will not be in the language. If it is so, that language is not regular. Otherwise, the language is called regular language. So you get contradiction, then we need. But then language of palindromes. The CFL is because suppose a recursive substitution. This is because we can construct a grammar like this. These are the productions. A implies epsilon, A implies 0, A implies 1, A implies A0. These are the productions. These are all terminals. The first it may be a non-terminal. Variable may be or called as a non-terminal. This is production listed as follows. The grammar. How does the context grammar for palindromes work? An input string belongs to the language accepted if it can be generated by the contextual grammar. These are the productions of the grammar. For example, 0, 110. G can generate W as follows. If they choose productions from the allow, which will be accept for that matching for the given input string. Every step substitute one variable of its own production. First one, A, which is matching our input 0, which production is matching to us, A0, A is matching, we select the particular production. Next, A is a variable which will be expanded. This production will choose the A1, chosen which is matching to our second input. Similarly, all the inputs are replaced, which terminals are replaced, finally get them input string which is matching to our original. So this sentence is generated from the grammar. Okay. So this input is accepted by the PDA. Context by grammar definition. The context by grammar are 4 components, which is called VTPS. V is a variable, P is a terminal, P is a production. This is the starting symbol of the grammar. Terminal symbols, set of productions, where all the productions like this, where this is the start symbol of the grammar. A context by grammar for the language of bilingual palindrome is 0 power n D. Against this given input string accepted. More examples. Wherein this is matching in the code, syntax checking. The scenarios where there is a general need for matching a symbol, another symbol, matching a count to one symbol with another symbol, recursive substituting one symbol with a string of other symbol. Simple expressions. We can rewrite context by grammar for accepting simple expressions. VTPS. V is a set of variables. P is a set of terminals. S is a starting symbol is V. P is a set of productions like this. 2 set of productions E and F. Contextual language. VTP is already designed. Leftmost and rightmost derivations, for example. So this is a grammar. This is a productions listed here. This is the input sentence. We have to generate the leftmost derivation from this grammar. Always substitute leftmost variable. Leftmost variable you have to substitute. First one. Starting symbol is E. And which symbol you have to substitute for this input? A star bracket. This means you have to choose for the star. E star, E is the production is there. You have to choose this production. Next, leftmost variable is E. E you have to replace. F. F is leftmost variable. F you have to replace AF. So F is a leftmost variable. You have to replace by epsilon. So A into E, we got it. Now E is only variable is available in this group. So E to be expanded. You need AB plus 10 0. So you have to choose which production matching for this group. So E will be replaced by bracket B. Again, E will be replaced by E plus E. Leftmost E is E. So it should be replaced by F. F will be replaced by A. Again, F will be replaced by BF. Now F will be substituted epsilon. We get AB plus one more is E is there. Again, we substitute E plus E replaced by F. F should be 1. So finally, you get the final string input string. So A star within bracket AB plus 1 0 close the bracket. This is a string which is generated from this grammar. It's the leftmost direction. Similarly, rightmost derivations also do the same thing. Starting symbol is E. This production you have to choose for the int E. Rightmost non-terminal will be expanded first E. So this E is to be replaced by E. Rightmost non-terminal F. F will be replaced 1F. The one F will be again 0 will be replaced by again F will be substituted by epsilon. We will get next one more leftmost rightmost variable is E. Be replaced by F AF. Then ABF. Similarly, AB 10 is there. Similarly, come to left hand side. C is there. E will be replaced by F. F will be replaced by A. So AF will be again substituted by epsilon. A will be get. So these are the leftmost and rightmost derivations. So every leftmost derivation, there is a rightmost derivation, vice versa, true or false. So true. We'll use positive to prove this. Does every word generated by the context will have a leftmost and rightmost derivation? Yes. Easy to prove. Reverse direction. Could there be words which have more than one leftmost and rightmost derivation? This also yes. So again, this is context free grammar is ambiguous. Positive. This is a positive looking. This it will like this syntax tree. So each internal nodes are not terminals, external nodes are terminals. Example. This is a positive for the input string 0, 1, 1, 0. Is all the internal nodes are variables. All the x nodes are terminals. We are starting from 0, 1, epsilon, 1, 0. We have combined all these terminal symbols means we get 0, 1, 0, 0. This is a positive for this input 0, 1, 1, 0. Similarly, positive for A, 0, 1. Similarly, the same grammar we expanded again. Like all internal source are variables, all x nodes are terminal A plus 1. This is a positive for A plus 1 input string. Is a recursive for inference. It's a derivation. Recursive inference goes to bottom to top. Derivation goes to top to bottom. Recursive inference, bottom to top. Derivation goes to bottom, top to bottom. Thank you for this lesson. Thank you, and all.